The product rule. Up until now, if asked to differentiate functions, such as these, we've used distribution as the first requirement prior to finding the derivative using the power rule. Now, this method works fine when it's simple distribution. However, what if distributing is impossible or quite difficult, like in this one? Do you literally want to use the distributive property 2 times through, combine like terms, and then do the derivative? Or do you want to try something else? For these cases, Gottfried Leibniz found out how to find the derivative of the product of 2 functions. This is known as the product rule. If 2 functions, f of x and g of x, are differentiable, then the derivative of y equals f of x times g of x is y prime is equal to the derivative of the first times the second plus the first times the derivative of the second. Now, since addition is commutative, my calc instructor in college actually had these switched around. He would say the product rule is the first times the derivative of the second plus the second times the derivative of the first. And again, that's also possible because addition is commutative and you would still get the same answer. Find the derivative of the following function, y equals x plus 1 times the quantity x minus 1. So if we apply the product rule to solve this problem, we have f prime of x, which is 1, times g of x, which is x minus 1, plus x plus 1, f of x, times the derivative of g of x, which is 1. If we multiply 1 times both of these binomials and then simplify, we get a final answer for y prime being 2x. Let's try one that's a little bit more challenging. Find the derivative of the function y is equal to the square root of x times the quantity 3x squared minus 1. We're going to start by rewriting our square root of x, or radical, as an exponent. So we have x to the 1/2 power times the quantity 3x squared minus 1. Now we can apply the product rule. And remember, the product rule is f prime of x, so 1/2 times x to the negative 1/2 times the first, so we just rewrite 3x squared minus 1, plus our first, x to the 1/2, times the derivative of the second, which is 6x. Our last step is to simplify. So we have 3x squared minus 1 over 2 times the square root of x plus 6x times the square root of x.